What we have here is a basic layout for what we're going to call an LOL chart. This is what we're going to use to analyze the energy changes when we're dealing with conservation of energy problems. So you start off with an XY axis on the left. That's going to represent your initial conditions and how much energy in each energy storage form you have to start. Then afterwards, we're going to have the final conditions over here on the right side. In the middle, you have a circle that represents the system, where you can represent the flow of energy either into or out of the system in terms of things like work or heat or radiation going into the system, adding joules of energy to the system, or in maybe some other problems, maybe some energy is released from the system, and so we'll show it as arrows that go out. In addition, each arrow is going to be representing so many joules of energy based on how many blocks of energy it's worth. So that would represent maybe 3 blocks of energy in that case. 3 joules of energy perhaps. Also, on these graphs, you're going to keep up with the different energy storage forms of kinetic, gravitational potential, and elastic potential energy as K, UG, and US. So if under the initial settings you have maybe 4 joules of kinetic energy and 2 joules of gravitational potential energy and maybe 0 joules of elastic potential energy, you can represent it as bars that way. They don't always have to be one individual square per 1 joule, they just have to be proportional to each other. And then after whatever situation happens and you have your final settings, you'll also have maybe some kinetic energy, gravitational potential energy, elastic potential energy, plus over here you're also going to have thermal or dissipated energy in case there was something like friction that was releasing energy as the process took place. And afterwards, if you started with 6 blocks of energy to start, maybe the object is moving slower and maybe it got to a higher elevation, and then maybe that only adds up to 4 blocks so far, so I still need 2 more blocks. Maybe the rest was transferred into thermal energy as it was dissipated due to friction. So the whole point of these is to be able to see that you have the same amount of energy before a situation happens as after. And we'll add math to these to figure out exactly how many joules we have before and after. Finally, you may have some problems where instead maybe some energy left the system as it took place in the form of the system doing work on the surroundings. So you could put a W there to represent the work. Actually, I think we usually put it at the tail end of that arrow. And maybe 2 blocks of energy left the system as work was done. So then it would make sense that you might only have a total of 4 joules still in the system at the end. So that's how these charts are going to work. And now we're going to solve some specific problems using these charts.